Okay, this is a simple summary on remainder and factor theorem. Alright, the choice of the keywords are up there. If you see exactly divisible or factor, you use the factor theorem. But if you see the word remainder, you will need to use the divisor to find the remainder that is given. Alright? It's very obvious in 3 part 1, the word remainder comes out. So clearly we must use the remainder theorem, and there is a remainder of 40 when divided by x minus 3. But the polynomial is not defined. We need to define by fx. After that, I write down what is the divisor and use the remainder theorem. So remainder theorem tells us we need to put x minus 3 equals 0. So this means the value of x is equal to 3 into the polynomial. So replace your x by 3 and solve accordingly. Okay, basically I need to just press a calculator and simplify. Oh teacher, I don't know how to do the next part. Oh please use your calculator. 3 to the power of something is 81. Try your luck. So if 3 to the power of 4 is equal to 81, is it very clear cut? Our n is equal to 4. There you have it. We are done for the first part. Okay, part 2. The keywords are factor. Oh, if this is a factor, this means that the remainder must be equal to 0. Am I right? Okay, there's another polynomial, but it's not defined. Because I don't want to confuse myself, even though it's a different question, instead of writing fx, I can write gx or hx. Alright? So I'm going to define first. Okay, I need to make use of the factor, but it's a quadratic factor. Meaning, if I want to use the factor theorem, I must factorize it to become linear. So remember, if you have a quadratic factor, you will need to factorize it for it to be linear to know what to substitute inside. Let me use x plus 3 first. Remember, when you use the factor theorem, the remainder is equal to 0. Now, I put negative 3 into all the x terms. Oh, but that is not the only factor. I have another factor. I got a bit of space. Let me do it on the right hand side. Let me use x minus 2 as the other factor now. Notice you have two sets of equations. There are two unknowns a and b. So our job is very simple. Just simplify the two equations, solve for simultaneous equation. Alright? So between two, I'll make one of it the subject. I choose the one that has smaller numbers. So I decide to do the one on the right. Some of you can already tell me, oh, teacher can reduce to lowest term. Of course. This means that the b can be equated to each other. We have seen that before also. Since they are the same, just solve accordingly. Okay, take note, just be very careful with our simultaneous equation. You should get to the two answers.